Section 2.1, Quadratic Functions. Part 1, Introduction to Quadratic Functions. A function f of x equals ax squared plus bx plus c, where a, b, and c are real numbers and a does not equal 0, is called a quadratic function. If a quadratic function is written in the form f of x equals a times x minus h squared plus k, for some real numbers h and k, we say that f is in standard form or vertex form. And here our vertex is the point hk. But if a quadratic function is written in the form f of x equals ax squared plus bx plus c, we say that f is in general form. And we'll talk about how to find the vertex of that function a little bit later. An example of a quadratic function in vertex form would be this. So we have f of x equals 2 times x minus 1 squared plus 3. In this function, our vertex is the point 1, 3. An example of a quadratic in general form would be negative 3x squared minus 2x minus 11. So let's graph the function f of x equals x minus 3 squared plus 2 by applying transformations to y equals x squared. Here's the graph of y equals x squared. Notice the vertex is right here at 0, 0. So what would the transformations look like? The x minus 3, that brings it to the right 3. And the plus 2 brings us up 2. Let's do one thing at a time. First, we'll move the whole graph to the right 3, and that gives us this green graph right here, the green. Well, now our vertex is right here, but we're not done. Now we need to do the plus 2. So now the whole graph is moved up 2, and our vertex is now here, and that is the point 3, 2. Our vertex is the point 3, 2, and the axis of symmetry. The axis of symmetry cuts the graph in half, so it's symmetric on both sides. So for a quadratic function, the axis of symmetry is a vertical line, and in this case, it's x equals 3. That 3 is the same 3 from the vertex. Let's look at the standard form of a quadratic function a little bit more. We have f of x equals a times x minus h squared plus k. Our vertex is hk. The axis of symmetry is the line x equals h. Concavity, that means that if a, the number in front here, is greater than 0, our quadratic function opens up. And if a is less than 0, our quadratic function opens down. So this was our function, and this was the graph. Notice we have the axis of symmetry and the vertex, just like we had before. The vertex is the point 3, 2. The axis of symmetry is x equals 3, and it opens up because the value in front here is a 1. Our a value is 1. 1 is positive, so our graph opens up. Let's determine the vertex, axis of symmetry, and concavity of f of x equals negative 3 times x plus 5 squared plus 7. This function is in the form a times x minus h squared plus k, where a is negative 3, h is negative 5. Notice the x minus a negative 5 gives us the x plus 5, and k is 7. So our vertex is hk, negative 5, 7. That gives us our vertex. The axis of symmetry is the line x equals negative 5. And the concavity, because a is less than 0, this parabola will open down. The general form of a quadratic function looks like f of x equals ax squared plus bx plus c. To find the vertex, we can use negative b over 2a for the x-coordinate of the vertex. And the y-coordinate of the vertex is the y-coordinate that goes with that x-coordinate, so f of negative b over 2a. Our axis of symmetry is represented by the line x equals negative b over 2a. The concavity Still the same, if the a value is greater than 0, it opens up, and if the a is less than 0, it opens down. One way to remember this, the negative b over 2a, that's just part of the quadratic formula. So if you already have the quadratic formula memorized, you're not memorizing anything new. The negative b over 2a is just the part of the quadratic formula that does not involve the square root. Let's find the vertex, axis of symmetry, and concavity of f of x equals 3x squared minus 12x minus 11. In this case, a is 3, b is negative 12, and c is negative 11. So our vertex, well, the x-coordinate of our vertex and our axis of symmetry is negative b over 2a, which in this case is negative 12 over 2 times 3. Two negatives make it positive, so we have 12 over 6, or 2. So my vertex will have 2 as the x-coordinate, and the axis of symmetry will be the line x equals 2. Let's find the y-coordinate of the vertex. To find the y-coordinate, we need f of 2, where 2 is our x-coordinate. So we have 3 times 2 squared minus 12 times 2 minus 11, or 3 times 4 minus 24 minus 11, 12 minus 24 minus 11, 12 minus 24 is negative 12, and negative 12 minus 11 is negative 23. So our vertex is the point 2, negative 23. The concavity, notice our a value is positive, so the graph of this function will open up.